So in this question, we are given on question number 2 that is a quadratic number pattern that we are supposed to consider, and also a geometric series. So those are the two that we are going to consider in this platform. So let us quickly have our question as we are given the first part on 2.1. They are saying the first four terms of a quadratic number pattern. All right. So these are the terms that you are given of a quadratic number pattern. So the question was write down the second difference. All right. So the second difference from these terms. So as we do understand, when you are to determine the nth term, you need that second difference is just a continuation. So whatever that you're going to apply, there you're going to use it to answer the following question. All right. So let us quickly have this one, guys, as we do understand. All right, so let me just have it this way. All right, so I'm gonna take the numbers as we do understand that the numbers that you'll be given on a quadratic, you're supposed to be given four terms. All right, you're supposed to be given four terms for a quadratic, and that is exactly what we are given here, so that we'll be able to have the second difference. So remember, your first differences, let us determine from our terms. This is the first one, second one, third, and so on and so on. So you're going to have the difference. Remember, T2 minus T1, the difference 282 minus 171. That was 111. The difference between these two, that was 105. The difference between these two, that was going to give us 99. All right, that's 486 minus 387. So this is it for the first differences that we have. Then we move on to the second. All right, so the second, let us determine the differences between the terms 105 minus 111. That was going to give us minus 6. 99 minus 105 was going to give us a negative 6. All right, so as we can see, guys, the constant second difference there is what is negative 6. So that was our second difference. All right, so the second difference, I'm just going to write in short. So our second difference was equal to negative 6. So it is just a continuation on 2.12 for you to determine the nth term. All right, the nth term of this pattern in the form. All right, so that format, you're supposed to be used to that format, guys. This is a quadratic. Whether you are given that, you're supposed to actually understand this format. All right, so that was so this is 2.11. So we're going to have 2.12. So as we do understand on a quadratic, the second difference, this part, we are going to equate this to 2a. So that is 2a is equal to minus 6. Simply divide by 2 by 2. So that is a is equal to minus 3. Then moving on to the 111, this part here, we are going to take this as 3a plus b. Remember, that's equal to 111. So 3a plus b is equal to 111. So substituting the value of a, which is minus 3, that was going to be 3 times minus 3 plus b, which is equal to 111. 3 times minus 3, that's negative 9 plus b, which is equal to 111. Taking the negative to the other side, it was going to be what? A positive. That's b is going to give us 120. All right, simplify this properly. You're going to have 120. Then from the first term, which is 171, we know that this is a plus b plus c. All right, so a plus b plus c is 171. So guys, mathematics is all about revision. You have to work out as many questions as you can, try to figure out how do they ask the questions, because they actually do repeat these questions. So just try to figure out. All right, so that is it, guys. Having our a, which is minus 3, our B, that is 120, plus C, this was going to give us 171. So add these two, that was going to give you 117 plus C, which is 171. So let us take the 117 to the other side. It is going to be a negative. So that C is equal to 54. So as we have our quadratic, remember, in the form of an squared plus bn plus c, we are simply going to substitute the a that we calculated, that is minus 3. So this is minus 3 n squared. The b, which is 120, so that is 120n. The c, that is 54. So that's what we are going to have at the end. So you see, guys, just like that, you have your Tn from this part, the one that you had. So it was just as an easier part that you are simply following. Then another question from the same quadratic pattern, they are saying another pattern with general term. So take note of that pattern. This is the general term of that pattern. All right. So this term is given, all right, which, that is the question now. Which term of this new pattern, which term will be the same as that of the quadratic, this one, which is the quadratic that we had before. As you can see, this is the one that we had before. Which term? That they will be the same thing. It is just like this is a linear function. It is just like you're answering the questions on functions. All right. You have a quadratic function that you have drawn. All right. You have got something of this nature. Then you've got a straight line that you have drawn. You've got something of this nature. At the point of intersection, we know that these two, they're equal. It is the same thing that is happening here. This linear pattern, as you can see, the highest exponent is 1. So that's a linear pattern. And that of the quadratic, because this part is forming the quadratic. They're saying at which value of n, the value of n, when the two will be the same, they will be equal, the two. So it means the Tn, this one, that's 2.13. All right, let us just have it here. That's 2.13. So it simply means Tn of the quadratic must be equal to Pn. That is, they are same. So what is our Tn? Remember your quadratic as it was here. You're going to take this quadratic minus 3n squared plus 120 plus 54. All right. So this is the part that we are going to have here. That is minus 3n squared plus 180n. All right, plus 54 is equal to Pn. Remember our Pn, this part as it is. All right, so we're going to equate. That is minus 60n plus 2754, just like that. We have formed an equation where you can solve for n, and this is a quadratic. The highest exponent there is 2. So remember your format. Ax squared plus bx plus c must be equal to 0. One side must be equal to 0. So we are forced to take these terms to the other side of the equation, or these ones to this side. So it's up to you. So you can take these terms, meaning to say we are going to have minus 3n squared minus 60 to the other side is going to be positive. So this will be positive 60n. That is, we are adding 180 plus 60, which is going to give us 120n. So that's 120n. We take this to the other side, it is going to be a negative. So that's negative 2754. So once you subtract, it was going to give you negative 2,700, which is equal to 0. You have taken all these terms to the other side of the equation. That is one side it is supposed to be equal to 0. Once we have this quadratic equation, we can solve, but you can easily reduce this. As we can see there, that's 3 is the highest common factor, but we can use negative 3 to make the coefficient of n squared a positive. So we're going to use negative 3, negative 3, negative 3 each and every term. So that was going to be n squared 120 divided to negative, that's negative. So this was going to be 60. All right. So that is 180. All right. So there we had this minus 120. This was minus 120. Where did I get the 180, guys? This was negative 120n, as we have this one as 120n here. Previously, I did a mix up here. So this one is just a mix up. It was supposed to be this way. Remember, it was supposed to be 120n. So the moment you take this negative to the other side, it is going to be what? Positive 60n. So you add so that this will be positive 180n. All right. So meaning to say, once you divide by a negative, positive, negative, that was going to be negative 60. So there we're going to have negative 60n. Negative, negative, that's a positive. So it was going to be positive 900, which is equal to 0. All right, so it is best that you do use the calculator and the simplification, but this one was not a issue of the calculator. It was issue of mistakenly writing this number and also adding there. So please make sure that you work out with the calculator. Always your calculator. You have your calculator, guys, okay? So that you do not have all these mistakes. So from this part, using the quadratic formula, using the factorization method, whatever method that you are capable of, simply factorize. In this case, you can use any method. So I'm just going to use factorization. The coefficient of n squared is 1. So I'm going to have n and n here. So considering the constant, remember, you work out from the constant, the 900 that we are seeing. 2 terms you multiply to obtain 900, but the same numbers when added are supposed to add up to negative 60. 2 terms, 2 numbers. You multiply the numbers, you obtain 900. Then negative 60. So having the 60, there's a possibility there from the 30 and the 30. But for us to have a negative 60, these numbers must be negative, negative. Negative times negative, remember, that's a positive. So it is going to give us positive 900. If we add these two, minus 30 plus minus 30, that is minus 60. So these are the numbers that we need. Minus 30, all right, and minus 30. So it is the same thing. There is just like you can even write it as n minus 30 squared. You can even write it that way. It is up to you, the way that you understand. All right, so calculating n, minus 30 to the other side was going to be positive. So that's a positive 30, or n is equal to positive 30 again. So we can just use one value there. It is, we are having this like 1 point of intersection. It can be like that. Remember, on the function, you can have a graph like this, then a line like this. They can intersect at 1 point. So this is the condition of our question. It is having the point of intersection at a single point, or they are the same, where n is equal to 30. We do not have any other condition where these two will be the same. So therefore, our n was going to be 30. All right, so this is it, guys. Exam, just make sure you work out your questions properly. Apply the given information from what you had. You calculated these, the TN, the PN, you were given this one. So it was just a matter of substitution. All right, so that was our question. Considering this part, you're given to study the geometric series. All right, so let's see our geometric series. We are already told it's a geometric, where we have got the common ratio, second term over what? The first term. So the question was, calculate the sum of the first 16 terms. All right, calculate the sum of the first 16 terms. So we are given, we can, okay, let's see. That's 2.21. So this is our first term, second term. So it means we can calculate R from there. Second term over first term, 1 over 16 like this, over, that is, we are going to divide by what? 1 over 8. So make sure you do use your calculator properly in that case. So this is 1/8. So that was going to give us 1/2 as the common ratio. By dividing these two, you've got 1/2, meaning to say our R is less than 1. So remember, if R is less than 1, you can use the formula Sn is equal to A into 1 minus R to the exponent of n, like this, over what? Over 1 minus R. Like I said, guys, you can even use the other one, which has got what? A into R to the exponent of n minus 1, like this, over R minus 1. Still, you are going to obtain the same answers there. All right, so we are given to calculate the sum for what? Of the first 16 terms. So the sum for the first 16 terms is equal to A being the first term, as we are given, that is 1/8 into 1 minus our R, which is the common ratio, that is 1/2, raised to the exponent of what? 16, the number of terms that you're given there. So that's 16. Then whatever that you're going to have here, we're going to divide to 1 minus, remember our R there is 1/2, as we calculated this one before. So this is 1/2. That was going to give us the sum by simplifying these values. All right, by simplifying this on our calculator, you are going to have a decimal 0,2, something like that, 0,2499996, like that. So to 2 decimal places, you can fix your calculator. I talked about that, or you can just round off. That was going to change to a 5. So that's 0,25 to 2 decimal places. So this is the sum. All right, this is the sum. Then on another part, question 2 point, all right, let us just remove this in case if we need this, then we are just gonna rewrite this part, all right? So we are given on another part, which has got 5 marks. Calculate the value of n such that we are given a statement there to consider. All right, let's figure out this statement. The sum to infinity minus Tn, it is supposed to be equal to 1023 over 4096. The sum to infinity minus Tn. So this one, it's an equation that we are going to form. The sum to infinity and the Tn. That's an equation, this one. All right, let's work out this part, guys. Remember, the sum to infinite, we are supposed to know this. I also referred to this one on its own. So remember, I said the sum to infinity. You're also given this in your formula sheet, so do not worry about this. So this is given as A over 1 minus R. Okay, we can calculate this. All right, remember, we have got A everything, like in this case, A being our first term. Remember, that is 1/8 from our series. So that is 1/8. Okay, this is our A, everything over what? 1 minus R, which is our common ratio. Remember, our common ratio was 1/2. We calculated this. This is 1/2. So we are going to substitute 1 minus 1/2, like this. So this is going to give us the sum to infinite by substituting this. Right, so this one, you just need a calculator, guys. It was going to give you 1/4 or 0,25 as a decimal. That is the sum to infinite. So we have this one. What about Tn? Tn of a geometric. How do you calculate Tn under a geometric? All right, we have our R there, and also we have the part of A, which is our first term. Remember, Tn. So I'm just gonna, let me just have it here so that utilize this space here. Remember that Tn of a geometric series is given as AR to the exponent of n minus 1. So we can substitute this. Tn is equal to A being the first term. Remember, our A, we said, is what? 1/8. We can even take it from our previous part. That's A, 1/8. Our R is 1/2. So that's 1/2 to the exponent of n minus 1. This is our Tn. All right, this is the presentation of our Tn. So we've got the sum to infinity. We also have Tn. So we can substitute into this equation. It's an equation, this one. It's a statement. It's a given statement. So following this statement, they are saying the sum to infinity, which is what? 1 over 4. That is our sum to infinity. Minus Tn, which is what? What is our Tn? Remember, we calculated this Tn, which is this part. So we are going to substitute that Tn as it is, all right? Remember, our Tn was, or it is 1 over 8 into 1 over 2 to the exponent of n minus 1. This part, it is supposed to be equal to this number, which is what? 1023 over 4096. That is our question. That was the condition of our question. So you have to find your Tn, the sum to infinity, then substitute now into the equation, the statement that you are given. It is a given statement that you have to follow. So from this, we can calculate the value of n, because we can see that we have formed an equation. And in this equation, it is only n that we have as the unknown. That is the only unknown that we have. So we can solve for that unknown. Okay? So how can we solve here, guys? We can get rid of the 1 over 4, take it to the other side. It is going to be negative 1 over 4. So meaning to say we are going to remain with this part. As you can see, it has got a negative. Negative 1 over 8. So this is negative 1 over 8 into what? 1 over 2 to the exponent of n minus 1 is equal to, remember, we took this to the other side. So it is going to subtract there. All right. We are going to have a difference. This number minus this. So that was going to give us negative 1 over 4096, like that. Okay, this is what you're going to have. As we can see, the 1 over 8 or the minus 1 over 8 here is a product. We are multiplying. So how can we get rid of that minus 1 over 8? We can get rid of this by dividing by that minus 1 over 8, both sides of our equation. We are supposed to divide by minus 1 over 8 so that these can cancel. You are remaining with what? 1 over 2. So that was going to be 1 over 2 to the exponent of n minus 1, which is equal to what? You have to divide now these two. So this one is just like we've got a bracket like this. So is this bracket divided to this bracket. Make sure you use your calculator properly. That was going to give us a fraction, all right, which is 1 over 512. This is what we have. Remember exponents. As you are solving, you are back to exponents now. Your exponents, how do you solve this? Make sure that you are having the same base, 1 over 2. So can we have 1 over 52 in the base of 1 over 2? So this one, guys, it's a trial and error where you can use your calculator to try until you get that value that you are given, which is 1 over 512. You can try, because what you know is that you are having 1 over 2 as your base. So you can use your calculator, 1 over 2. You try until you get that 512. So if you know, the answer is fine. In this case, we're supposed to be to the exponent of 9. But let's say you do not know. You try a 7. You see this is 1 over 128. You are not having the answer. You move on. You press 8. You move on. This is 256. We put a 9 in this case until we obtain this value, which is 1 over what? 512. Until we have that value. So it means it is 1 over 2 being raised to the exponent of what? To the exponent of 9. So that is 1 over 2 to the exponent of n minus 1 is equal to this side. This is 1 over 2 raised to the exponent of 9. To obtain this, yes, you can have that one of removing the fraction. Guys, it's up to you, but you can even work with that 1 over 2 as it is. So as we have these bases being the same, the 1 over 2 and the 1 over 2, we are simply going to equate the exponents. Therefore, n minus 1 must be equal to what? 9. So taking the minus 1 to the other side, it was going to be a positive 1, meaning to say n is equal to what? 10. That is the condition. That is our condition. So this is the value of n that we are being asked at a condition where we are given that the sum to infinity minus Tn is equal to this. So some of these questions, you form an equation from the given statement. So they are going to ask maybe another typical question of this nature, but only different values being used. You follow up same way, answering of the questions. It is easier that way. You find whatever that you're given, they can talk about maybe it's S3 or it's S4. Calculate S4 because you have the formula for the sum of terms. You calculate, just like here when we calculated this one, the sum for the first 16 terms. So they can give you as an equation, maybe the sum for the first 4 terms minus Tn is equal to whatever that you're given. You have to find whatever that you're given here and your Tn equate to whatever that you're given. That's you have formed an equation. Solve. That's how these questions can be given. So let us do as much revisions, guys. Let us try as much.